Hello guys, this is a short little mini video going over the vocabulary for 1.01, which is Geometric Terms 1. So this is just the very basics of geometry because this is our very first lesson. Okay, so we're talking about undefined terms, lines, line segments, rays, collinear, non-collinear, intersections, and we're also going to talk about coplanar and non-coplanar. So let's get going. So when Euclid created geometry, he said, and he told everyone that at the very beginning, I'm going to have three terms that they don't have definitions, which seem kind of odd because all other math has defined terms, right? But he said these things are the point, line, and plane. I can't really define them. I can just describe them. So that's why point, line, and plane don't have a true definition. And we call those undefined terms so they're kind of like the building blocks of geometry. Everything is based on point, line, and plane. So the point, it's just a simple location. It's drawn with a dot. The important part is that it doesn't have a shape or size, and it's very important how you name them. So we name a point by just a capital print letter, okay? A capital letter. The next one is a line. Key things to take away there is that a line extends infinitely, so it continues going in both directions. Also, a line, if you have 2 points, that means that there's infinite number of points in between there, okay? So infinite amount of points all down that line, or all the way out here as well, okay? Another thing to take note is that any 2 points, you can draw a line through any 2 points. It doesn't matter where they're located. You can always draw a line through 2 points. When we name a line, we name it with a lowercase cursive letter or a lowercase script letter, like that N right there, okay? The last one is a plane, and you can just think of that as a flat surface. So just like with the line, how it extended infinitely, the plane can extend indefinitely. So a plane extends in all directions. So it is a flat surface that extends everywhere, all directions. It's normally drawn by, they might shade it if it's on a figure. It also can be drawn with a slanted four-sided figure that is shown here above, okay? To name the plane, you can use one capital cursive letter, or you can use 3 points that are on the plane that are non-collinear, meaning they're not on the same line. So we could say plane ZXY, okay? And just like, remember how I said that with the line, you could draw a line between 2 points. For a plane, there is exactly one plane for every 3 non-collinear points, okay? Let's take a look at types of lines. So the basic line continues infinitely in both directions, we said, okay? We know that. To name a line for this example here, we could say AB, and we would put the line above it, but we have to put the arrows to show that it extends in both directions, okay? You also could say BA as well. That's fine. For the line segment, we could say AB, and we just draw the line above it. We don't put the arrows on there, okay? We do not put the arrows on there. A line segment is part of a line, so it has a starting and a stopping point, or it has 2 endpoints there, okay? The other one is a ray. Now, I can think all the way back to elementary school, and I remember my teacher talking or using the example of a flashlight for a ray. You can hold that flashlight in your hand. That's the starting point of the ray, and the light continues infinitely, right? So that it goes off into that direction. That's what a ray is. It has a starting point, and then it continues on. So this ray starts at A and goes through B. And remember, continues infinitely in one direction. Now, when it comes to labeling this ray, we have to start with the letter of the starting point, okay? So it starts at A, and then the second point is the direction it is going. So we start at A and go through B, and we put that arrowhead on there to show that it extends infinitely. Now, I want you to be careful because this is where people mess up. Okay. Now I know that over here in the line, I said that we could call it AB or we could do BA, right? Because it extends in both directions. With the line segment, we could say AB or we could say BA. But with the ray, if we say BA, that means we're starting at B and going through A, which would be this ray here. Start at B and go through A. Well, that's a totally different ray than the AB, okay? So please be careful that when you're notating, when you're labeling rays, or when you're reading context, pay close attention to that starting point and what direction the ray is going, okay? And I am going to take this off because we do not want to call that ray BA. Okay, let's talk about intersections of lines and planes. This guy's easy. For two lines always intersect at one point. And that visual shows us that point P represents the intersection of line AB and line CD. This one was easy because it has a picture, but pay close attention that whenever you don't have a picture, remember you can always go draw the picture. Okay, and we'll talk about that in just a second for an example. For the intersection of two planes, like with these two note cards, they are going to intersect at line DC. So two planes will intersect at a line. So I'm going to say these again. Two lines intersect at one point. Two planes intersect at a line. Okay, let's look at a quick example here because I want to make sure I don't make this video too long. This is a cube, okay? How many planes are illustrated? So just think about it. How many flat faces or flat surfaces are on a cube? Well, just like with a dice, we would have 6. Name a plane that forms the floor. Okay, so that's this guy here. So we could call this plane. And remember, we only have to use 3 points. So I could just say plane ABC. Okay, name the plane that forms the left wall. So the left wall is going to be this guy over here. I don't have to go in alphabetical order when I'm named these. To show an example of that, I'll just say FEA. Okay, name the intersection. I'm going to erase these here. Name the intersection. Now, let's pretend, so don't look over there at the picture, okay? Name the intersection of line AD and line CD. So let's think of these. They both have that D in common. Huh. So let's now go draw them. You've got line AD and line CD. So those two lines, remember, two lines intersect at a point. So these two lines intersect at point D. So we could have answered that question without the picture. Okay, so look to see what they have in common, and that's going to tell you where they intersect. So for us here on this one, you have FB and BC. B and B. So these intersect at point B as in boy. Okay, name the intersection of planes ABE and BFC. Okay, A, B, and E. That's going to be this plane here. And the next plane would be BFC. Remember, two planes intersect at a line. So these two planes are going to intersect at line FB. FB, or you could also call it BF, right? Because it's a line and it extends infinitely. Okay, the last question here wants to know where plane AHD, so AHD, that's this first one, and intersection of BCA. What do they have in common? Where do they intersect? Right here at line AD. Remember, two planes intersect at a line. If you need to, guys, rewind the video, go back and watch those examples again. Even go back to the beginning of the example, pause it, and see if you can answer these questions on your own, okay? Okay, we're going to jump to, we got 4 more vocabulary words, okay, for this lesson. We have collinear, coplanar, non-collinear, and non-coplanar. So this first one, collinear, you've got that line in there. What that means is collinear means that you have lines that are on this, or you have points that are on the same line. So that would be this guy right here. Notice that A, B, and C all fall on the same line. So the example below it, you've got A and C on this line. However, then you have B over here. So A and C are not on the same line as B. So this is an example of non-collinear. Okay. Let's pretend, and I don't know what happened to my figure. Let's pretend that's closed. So when we have all 3 of these points, A, B, and C, and they're all on the same plane, this is going to be called coplanar. But then here, when we have A and C on the plane, but B off the plane, that is non-coplanar. Easy enough, right? So to be coplanar, they have to be on the same plane. And if they're not on the same plane, then they're called non-coplanar. Okay, let's look at a quick example here. Check to see what set of points are collinear. So the first one says M, Q, and X. Are those on the same line? Are they collinear? No, they are not collinear. Maybe I should just leave that off, the X. They are not, okay? Let's look here at the next ones. Okay, we have P, X, Q. Those are all on the same line right here. So those are collinear. Okay, the next one says M, P, and X. Again, those are not on the same line, so those are not collinear. Those are non-collinear, right? Okay, the next one says N, M, and X. Now, even though those don't go in order, like when they were named, they are on the same line. So those 3 points are collinear. Okay, guys. Remember, make sure that you are going through the content for the practice problems. There are so many practice problems that will really help you, and they give you quick feedback so you can see where if you're misunderstanding anything. Also, the lesson's full of vocabulary, so be sure to review the vocabulary words and use your notes when you're completing the assignments. Thanks a lot. Bye-bye.